Welcome. So this lab is on OSPF. For those of you that have been following along with my campus network architecture labs, let me show you where this would fit in. If you haven't been, or we're not there yet from some of my other classes, then ignore everything I'm about ready to say for the next few minutes. But we've configured in my campus network architecture lab series, the access and distribution layers. In this lab here, this would be the core layer, and we're going to be configuring OSPF. We'd also configure OSPF between the core layer and the distribution layer, multi-layer switches, and also between the distribution layer switches. So all of this here would be OSPF layer 3. Okay, I'm going to move that out of the way because that would be just for those of you following along with the campus network architecture. Okay, so let's focus on OSPF. What I have here are 4 layer 3 switches and 2 routers. The layer 3 switches, by default, their ports are, the ones that I'm using are 4331 switches. These are layer 2 ports by default. This is why spanning tree is running, and I'm showing the link lights. So what that means is if these devices here were all in the same network, so these wouldn't be separate IP networks. This would be all one IP. Well, it could be separate IP networks and VLANs and trunking. But what I want you to notice is the only active links that we have is anything from this device going to this device would have to travel from here to here to here to here. Spanning tree is blocking certain ports. Okay, you'll notice once we configure these as all layer 3 ports, then all these interfaces will be active. So let's get started. Okay, so all these devices here have only been configured with the basics. No IP domain lookup, line console 0, but no, with logging synchronous and exec timeout 00. So no IP addressing on any of the interfaces. So what I'm going to do is I'm going to configure the IP addresses for each one of these interfaces. So let me start here with MLS1 here, and I'm going to just copy and paste here to make life easier for all of us. I'm not going to show it for all the devices, but let me just show an example here. So I'm just going to copy this in from my text document. I'll show you what I work with. So I do everything on a text document. All right. So I have everything ready to go, and I just copy and paste. Something you may want to do. Okay, you can see that's all working. Let me do MLS2 here as well. Copy this. Okay. Copy this, go over to MLS2. And you're going to see all the link lights start turning green because no more spanning tree here. We are just all doing, these are all becoming layer 3 ports. I do want to mention that the commands that I'm using here, okay, is just the interface, and I'm using no switch port. This turns a layer 2 port into a layer 3 port on layer 3 switches. Depends on the model of the switch. Sometimes this layer 3 is the default. Sometimes layer 2 is the default. So this is just making this a routed port. Okay, so after that, we just treat it like a port on a router. So what I'm going to do is I'm going to pause the recording here, and I'm going to configure the rest of these and the routers. Okay, so I've configured all the IP addressing. You can see we have all green link lights now, no spanning tree running between I'm going to call these routers. Okay, they're layer 3 switches, but everything's acting as a router here. You'll notice our internal 10 network ends at edge. So the edge router is what connects us to our ISP. We have a separate network here. We'll be talking more about this in a moment. The ISP router, what I've done is I've created what's called a loopback interface. I'm going to show you this in a moment with an IP address of quad 99. That's what we're going to use to be able to test our reachability to and from the quote unquote internet. So let me bring up that router here. And you can see what I've done here is I created this is the interface loopback 0. It's a virtual interface. Okay, it's always up. And you can treat it like a regular interface, meaning I could route for it, I can ping it, I could SSH into it, whatever I wanted to do. We sometimes use these in various cases. There are use cases with BGP and even OSPF that I won't get into here. But like if you have a physical router, you don't have enough LAN interfaces, you can, in doing a lab, you can make loopback interfaces and you can route them and do all kinds of cool things. Okay, anyway, let's get beyond that. What I want to show you right now, let me move this up here, go over here, is let's go to MLS1. So as you can see here, I added all these interfaces, okay? And all these ports are up because the router on the other end also has a IP address and the state is up. So, but what I want to show you here, I'm going to do exit and show IP route. This is key. So let's look at the routing table. Now the router knows about its directly connected networks for all of these networks. Okay, these are all just like your computer, when you add an IP address and subnet mask, it knows what network it's on. Okay, so does the router. As soon as we add an IP address and a subnet mask to a specific interface, it knows, hey, I belong to that network. Okay, and we are using /30 networks for our inter-router links. Okay, that's one of the issues with IPv4. We have to do that to conserve IPv4 addressing. I won't get into that. I do want you to notice I did show IP route here, and it shows directly connected networks. That's all correct. The one thing it's not showing me in Packet Tracer are the local routes. And that's just a bug in this version of Packet Tracer with this device. If I do the same command, by the way, I can use the do in front of any show command when I'm in global configuration mode. When I do show IP route for the edge, notice it shows me my directly connected networks for the interfaces that I configured, but also shows a local route. This is the /32 for IPv4. That is showing the IP address of that device. Okay. That's actually used, so when it gets a packet that is actually destined for the device, like you're trying to ping it or SSH into it, it can more efficiently process that packet and say, oh, it's not for something I need to forward. This is actually for me. But what's important here is that is not being shown for our layer 3 switches, which is fine. It's just fine. All right. With all that out of the way, let's start the basic OSPF configuration because it is quite simple. Okay. So I'm going to start it here on MLS1. And I'll move this out of the way so we can see what we're doing here. Okay. But it's very simple. All I need to do is I'm going to go into here. I'm just going to say router, OSPF, and then give a process ID. I'm just going to make it a 1. This process ID can be anything from 1 to 65,535. I talk much more about this. Oh, and so much more in the lab. So much more going on in my lab document. Okay, so be sure you have access to that. I have it in my GitHub repository. All right, so all I have to do here is give it my directly connected networks. First thing I'm going to do, though, is give it a OSPF router ID. Okay, this is just a 32-bit value that's written as an IPv4 address. It's not an IPv4 address. And I'm just going to call this quad 1 because this is MLS1, and I like to keep things simple here. Okay, then I'm going to use the network command, OSPF network command, and all I do is give it the address of a directly connected network, like 10.1.1.0. Now, I can give it a subnet mask here, but OSPF actually uses what's called wildcard masks, the inverse of a subnet mask. You just take the subnet mask, take quad 255, subtract it from the subnet mask, and you get this wildcard mask. I talk about it in the lab. Don't get me started on that. Okay, wildcard mask. Anyway, you can do, by the way, and I'll show this later, you can use the subnet mask and OSPF will convert it into the wildcard mask. But let me just show the wildcard mask here. I'll do it at least the proper way for this router. And then area 0. This is single area OSPF. It is best practice to use area 0, although you can use any area number you want here, but it's best practice to use area 0 when you're running single area OSPF. This is going to be the same on all of our routers. This is going to be the same on all of our routers, but the process ID does not have to be. It's locally significant, but best practice and make your life easier, make it the same on all your routers. Okay, so that's all we're going to do here. What I'm going to do is actually copy and paste the other ones. Because Rick is lazy. Nah, not lazy, just make my life easier. Okay, so this, I did it for each network, each of its directly connected networks. You can see that I used the wildcard mask for each one. Okay, now there's something else we have to do here that we should do once we create, and this is because we changed the router ID. The lab document talks about how OSPF router IDs are created. The router ID, I won't go into all that here, but if we want this router ID to take effect, there is one thing we do need to do, and I'm going to do that right here. I'm going to do end, and I'm going to do clear IP OSPF process. I'm going to answer yes. Okay, and I'm going to show you something, show IP. Don't worry about this right now. Show IP protocols. This shows right here that, I'll talk more about this command in a moment. We're running OSPF process ID 1, and there's our router ID. So it did take effect after we reset the OSPF process. Okay, so I'm going to move this out of the way. And then what I'm going to do right now is, let me configure the other router. So let me go to MLS2 here. Okay, I'm already in global configuration mode. I'm going to do the same thing here, but I'm going to show you can do a little differently. And I'm just going to paste everything in there. Notice what I did here is I used the subnet masks, okay, instead of the wildcard masks. That's okay. What OSPF will do, the Cisco iOS will do, is when you look at the running config, it will be shown as the wildcard mask, not the subnet mask, but you can configure it with the subnet mask. Okay, but if you're looking at doing CCNA or any CCNP or any certifications, understand the wildcard mask. Okay. All right. Also, what I did is I did the clear IP OSPF process, and you'll see that at least on this network here, you're going to see messages coming up. Hey, OSPF adjacency. Hey, I formed a neighbor relationship. I talk a lot about this in my class. It's also in the lab, but I formed a neighbor adjacency on my gig 013 port with this neighbor here, quad 1. Hey, we formed an OSPF neighbor adjacency. Okay, let me do a couple of others because it's going to show you how I do these slightly different. Let's do MLS3. I'm going to copy this, go down here, going to paste it. All right. Here, you notice what I did was I used a quad 0 wildcard mask. Be consistent when you do this in the real world. However you do it the same on all of them, just to make your life easier. But I'm showing you the different ways. Quad 0 wildcard masks means this specific interface. So I gave the actual IP address of the interface, and it says you got to match all 32 of those bits. That's the interface I'm enabling OSPF on. Okay, that's just another way. Now I'm going to show you one more way. Why not? Yes, let's make life interesting. A lot of this is as we progress in the ways of doing things and finding better ways. uh, giving us more options. So it's not like the Cisco is purposely trying to confuse us. May seem that way at times, but not just Cisco, any network vendor. All right, so here you can see something a little different. Okay, it's forming the adjacencies. Okay, you done? You done? Probably not. But I went to router OSPF. There's my router ID, and then I did exit. I went into actually each of the interfaces, and I said IP OSPF1. So IP means, by the way, IP version 4. If we put a V6 there, we'd be doing it for IPv6, OSPF v3. Another video. This and the area. So you see that I've done it, just enabled it directly on the interfaces. Now you can see we formed a lot of adjacencies here. So a lot of good stuff happening here. Okay. We'll talk more about that in a moment. Let's go up here to Edge, because Edge, we're going to be running OSPF just from Edge down. So just in our 10 networks, we are not going to be running OSPF with our ISP. But this, in this case here, we're going to do a static route between us. Typically, what you run outside your network with an external network or ISP would be either static routes or a different routing protocol, or maybe even OSPF, but a different process ID that is part of your ISP's routing domain, or even BGP. But all that's all for other videos. We're going to keep it simple. In a moment, we're just going to be just doing static routes. So let me go to the Edge router. Don't want to forget Edge. And in this case, I'm just going to run it on one network. So let me paste this in. So I'm only running it on this network here. So you can see my configurations. I'm just running it on the 10 network, 10.200.200.24 network. Okay. All right. I think we're looking pretty good here. So my lab document in the lecture, we talk all about what's happening here, but we are basically with these commands enabling these interfaces for OSPF, which means we're looking at forming neighbor adjacencies with any routers out there. We're looking at sharing link state database information and learning about, with that link state database information, learning about remote networks. Okay, next. I'm trying to go through this as fast as I can here so I don't bore you with too much stuff, but let's go to MLS1 and the great command here to see what the verify OSPF. So one of the nicest commands I like to use is show IP OSPF neighbor. This will tell me who my neighbors are. And I should have 4 neighbors. Who are my neighbors? Okay, let me move that away. I should have Edge as a neighbor, MLS2 as a neighbor, MLS4 as a neighbor, MLS3 as a neighbor. Okay, what I should see is their router IDs. And here we go. There they are. There's MLS3, MLS2, MLS4, and there's our Edge router. That's the router ID, OSPF router ID for Edge. Okay, what else I should see is that we are in full state. Okay, that means we have exchanged complete data link state database information that we needed to exchange, and we're all set. We'll talk about this dead timer in a moment. There's the IP address of my neighbor, and this is my interface I use to reach that neighbor. Okay, don't worry about the BDR thing. We'll talk about that talk about it in the lab. We'll address it here a little later here. Okay. All right, that's one. Let's take a look. Actually, while we're here, let's take a look at a few other things. How about show IP OSPF? One IP and IP OSPF interface, and let's look at a specific interface. Let's look at our connection with MLS2, quad 2 router ID. So I'm just going to do gigabit 103. Whoops. There we go. Okay, so this is my connection with my adjacency with this router here. Now, what I'm looking at is specifically OSPF information. Wow, cool stuff here. Okay, this is telling me about my process ID, my router ID. We'll talk more about this in a moment. This is network type broadcast, which means it's Ethernet, cost of 1. That's talk more about that in a moment, but that's the uses bandwidth. Some other things here. Don't worry about some of this other stuff, designated router, backup designated router. We'll talk about that a little later, but it shows some other things like our hello and dead timer. I'll talk about that a little later. Neighbor means I have one neighbor on this interface, and it is this router ID quad 2. Okay, that's pretty cool stuff there. Let's do show IP protocols. I showed this once before. So much good stuff. How do you spell protocols? Let's see. There we go. Okay, so this tells me any information I'm running as far as my dynamic routing protocols. In this case, it says I'm running OSPF. Here's my router ID for OSPF. We'll talk about some of this other stuff later. I am routing for these networks here. These are the networks that I have OSPF configured on. Okay, and where am I getting some of my routing sources? From these neighbors here. The distance is 110. That's actually administrative distance for OSPF. Okay, some good stuff here. Now, I've mentioned the link state database. I talk about this in my class. We can actually see a summary of the link state database. I'm not going to go into it here. When I teach my CCNP level classes, I go into it in a lot of detail. Okay, but that shows a summary of the link state database. This can be very useful when you're really trying to figure out, why you're seeing something that you shouldn't see or why you're not seeing something that you should see. That really does help. Now, ultimately, what do we want to see? We want to look at the routing table. What should we see? That's a big part of understanding networking, is not just take whatever it's showing you, go, oh, I guess that's what it should happen. No, understand what you should see. Is there anything that you're seeing that shouldn't be there? Is there anything that should be there that you're not seeing? So, for example, MLS, what do we expect to see? Well, we've already noticed that we have our directly connected network. We've seen those when I did the show IP route earlier before I configured OSPF. What else I should see? Any remote networks. What are the remote networks? Well, this is a remote network. 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 Even this is a remote network. Okay. Now, I won't see this or anything here because I haven't configured anything that allows me to see any of that yet. But if we're all running OSPF and implemented correctly and we've converged, then I should be seeing your remote networks. You should be seeing my network that I'm letting you know I'm connected to. Let's take a look. Show IP route. Let's just do OSPF. What do I know via OSPF? And here they are. Okay. So if I kind of move that right there, we can see I see the 2.10.220, 10.330, 10.440, and I see that 200.4. Where are you? 200.4. You're somewhere here. Here you are, down here. 200.12. Where are you? You're over here. 200.20. You're right there. So I'm seeing everything. Okay, and I can also do show IP route. Just see the whole routing table. And I'll see all of that along with my directly connected networks, but I don't see anything here or out here, and that's fine because we haven't done that yet. Okay. Let me just move that out of the way. We could do the same thing if I wanted on MLS4. Okay. Yes. All the remote networks, including, there's that network right there. Oh, this is so good. All right. So, these devices here should be able to have complete reachability within our network. Okay, and you can test that. I have the PCs in the startup config. So I've given you a startup config file, by the way, for all of this. These are already configured. Everybody should be able to ping everybody in their network. But how about out here? Well, as we've seen, these routers here do not have anything for outside their network. They don't have anything in their routing table. Okay, so what we're going to do here is on Edge, we are going to configure, I'll move that right there for now. We're going to configure a static default route to point to the ISP. And on ISP, let me go there as well. We're actually going to configure a static route pointing to 10.0.0 network. So let's start here. On ISP, what I'm going to do is do IP route 10.0.0.0. And then I say for anything in this network, I'm sending it to you, Edge. Okay. And I'm going to send it to your IP address that we share this network so I can reach you because I'm directly connected to it. So I'm going to send it to you at 209.1.1.1. Does that look good to everybody? All right. Okay. And I can actually verify this. I'll just do end here, show IP route. Okay. I see my directly connected network. There's my loopback, right? Directly connected to that loopback. You know, we configure that interface. And here's my directly connected network here. Okay, so this is all I know about. And anything I send to the 10 network, anything that the first 8 bits is matching a 10, I'm sending it to you, Edge. Okay. All right. Now the Edge, what we want to do is configure a default static route pointing to ISP. So what I'm going to do here is say anything IP route, I don't care what it is, but if it doesn't match anything specific in my routing table, this is a default route, 0 bits have to match. I'm sending it to you, ISP, at 209.112. So let's do that. How do you spell 2? There we go. All right. Okay. Now, if I do, let's do a do show IP route, and I'm going to do static. And I can see that in my routing table. See this here? Okay, just like I did for OSPF, I can see just showing my static routes. Okay. So this means 0 bits have to match. If there's nothing more specific in my routing table, nothing matches a /24 or /30 of any of these, I'm sending it to you. Okay, 0, because 0 bits have to match for me to send it to you. All right, but we're not done yet, right? Edge has a default route, but we need to advertise that default route within OSPF. We need to have Edge tell, hey, all you other routers, I've got a way out of here. Okay, and I'm going to tell you about my way out of here via OSPF. Okay, so I'm going to do router OSPF1. Okay, and I'm going to use the command default dash information originate. What does that do? I've just advertised my default route to all these other routers via OSPF. Now they all have a default. Really? Yeah, let's take a look. So this is the routing table previously on MLS1. No default route, right? Let's hit that up arrow. Let's take a look. Show me now. Anything change? Oh, we got a more, maybe. Look at this. Hey, it just learned via OSPF, external type 2. Don't worry about that right now. OSPF, hey, I've got a default route. And anything that, if it doesn't match any of these, if I get a packet with destination IP address that doesn't match any of these networks specifically, given this as what has to match, prefix length, if 0 bits match, hey, I'm sending them to you, Edge. Hopefully you have a way out of here. Edge has that static default route going to the ISP. How about these other ones? Let's take a look at MLS4. Same thing. Let's just do show IP OSP route OSPF. And yes, it too. Of course, it's sending them to MLS1, and MLS1 will send it to Edge. The best path out, shortest path. OSPF, yeah. Hey, now we all have a default route. That was easy. Okay. You want to verify this? Let's take a look. I'm going to, from this router, I'm going to ping quad 999. Okay, ping 99.99.99.99. Okay. All right. Hey, we got that first one failed. What happened? An ARP request had to happen somewhere along the way, maybe more than one. Hey, let's really verify this. How about this PC here? Okay, desktop. Let's go here. Command prompt, IP config. I've already configured the IP addressing. So its default gateway is the local router, MLS4. Let's ping 99.99.99. Whoops, there we go. There we go. We've got reachability. Not only does this show that we have reachability from here to here, but it also tells us that ISP has a path back. Okay, we're one of those Alexandrian rules. Now, what if? Oh, I love this. Okay, this is a pro tip here. Love this stuff. What if MLS4 sends a packet for, let's do a trace route to 10.111.111.111. Hey, that's where's that gonna go? Okay. Let me actually, before I do that, let's do a show IP route. I'm going to do the complete show IP route here. Take a look at the complete routing table. So I'll show you there's no magic here. Okay. Okay, I'm going to do trace route again. 10.111.111.111. Now, we know about all these 10 networks, but I don't see any 10.111 here in any of these. So it's going to send it to its default, MLS1. MLS1 is going to do the same thing. Okay. It's going to say, hey, I don't have a 10.111 anywhere. I'm going to send it to my default route. I'll send it to Edge. Edge is going to say, you know what? I don't know about, let's do show IP route. It's going to say, I don't know about any 10.111.1, but I have a default. Hey, I have a default. I send everything that I don't know about. I send to the ISP. You know what ISP is going to say? You know what? Anything with a 10, I send to you, Edge. See what's going to happen? Edge is going to say, well, I send it to you. And so, yes, we're going to have a bit of a routing loop. We can show this right here. See this routing loop? Trace route will stop after 30 hops. Okay. So what's happening here is we are seeing messages from both this interface, because that's where the ICMP time exceeded message is coming from. So we're getting it from here and from here, but it is bouncing back here, back and forth. Okay. And if we do a ping, that will eventually be dropped, or any packets that we send to this address here will be dropped eventually when the TTL expires. Okay, we can see the same thing here, by the way. We can do it here. Trace RT 10.111.111.111. Okay, we're going to see the same thing happening. That bouncing back and forth. So here's our pro tip. We're going to configure what's called a discard route on Edge. So what we're going to do on Edge here is we are going to configure something. I'm going to go exit here. Okay. So what I'm going to configure is a discard static route, IP route 10.0.0.0, 255.0.0.0. What I want to do here, and I'll show you the whole thing, null zero. But before I hit enter, let me make this. What I want to do is this. I want to show you. If Edge gets a packet for anything belonging with 10 that in the routing table doesn't have a more specific MAC, these are our valid, legitimate networks that we actually have. Okay, but remember, we own the whole 10/8 network. This all belongs to us. If it exists within us. That means Edge should not be sending those packets to the ISP. So if it does get a packet for a network we own, but it does not have a more specific match, we got to drop it. Null 0, the bit bucket. Okay. Let's take a look at the routing table on Edge. Do show IP route. And what we see now is a static route for 10.0.0/8, which is the bit bucket. But so if it belongs to the 10 network, the destination IP address begins with a 10, first 8 bits, but there's no more specific match. Okay, we don't have a better match, drop it. Now, if it doesn't begin with a 10 and it's, not any of these, okay, then yeah, we still have a default route. This only applies if the first 8 bits is 10 and doesn't match something more specific. Okay. So now let's take a look at what happens if we do that same trace route. MLS4, let's do it. Okay. It gets dropped. Now, I won't get into the ICMP stuff here, but I just want you to see what happens if we do it here. Okay. Now it's still bouncing back and forth, but actually it's not bouncing back and forth. We're just getting time exceeded messages from Edge. I won't go into that, but notice it's all being dropped at Edge. Okay. So it's no longer bouncing back and forth. Sorry, I misspoke there. It's just being dropped here. So I don't have a route. I don't have a route. I don't have a route. I'm just so, okay. All right. No more bouncing. Great. All right. Next, what we want to do is take a look at, let's do this here. Okay. I'm going to do show IP OSPF. Show IP route OSPF. Just take a look at our OSPF routes. What I want you to notice is, I talk about this in the lab and my lecture, is how OSPF determines cost. Cisco uses, although the RFC doesn't mention what the vendor should use, Cisco uses bandwidth. Okay. And the only issue that we really have here is our auto cost reference bandwidth is set to 100 million, 10 to the 8th. Okay, but I'll talk about this more in my lab and in my lecture. But the issue with this is if we had any fast Ethernet interfaces, okay, they would have the same cost as our gigabit. So I show this in the lecture, but let's assume this was a fast Ethernet interface. Okay, this would be from MLS1 to get to this network here. This would actually be a faster path, okay, as far as bandwidth, a better path, because this is 1 gigabit, 1 gigabit, we'll say this 1 gigabit also, instead of 100 megabits and then 1 gigabit. Okay, it's shorter. And in fact, that it's only one router, but it's by taking the freeway here instead of a slow road here. But because the reference bandwidth is 10 to the 8th, 100 million, OSPF will look at this as the same cost as this. Okay, so this would be a cost of 1, 2. This would be cost of 1, 2, 3. What does it mean same cost? The links are all the same cost. So this would be still the better path if this was fast bandwidth. So what I'm getting at is we want to change our reference bandwidth. So if we had 100 megabit, 1 gigabit, 10 gigabit links, they'd all be differentiated as different cost within OSPF. So this fast Ethernet here would be looked at as a slower link than these gigabit links here. I talk about it in the lab. I don't want to take up a lot of time here, but I do want to show you the command to do this. Okay, so what I'm going to do here on MLS1 is this command here. Okay, I'm going to go into router OSPF 1. Okay, and I'm going to say auto cost reference bandwidth, and I'm just going to hit the tab here so you see it. Okay, and I give it the auto cost in megabits. Oh, why did they do this? Okay, 10,000. So this is actually going to modify my reference bandwidth to be from 100 megabits. It will make it from there. Let me go ahead and try to talk at the same time. All right. So it modifies it. So now I can have 10 gigabits. Is that what I was trying to get at? Changes my reference bandwidth higher. Okay. Now notice it says reference bandwidth has changed. Please change it across all routers. So give me a moment. I'm going to use the same command on all routers, including Edge. Okay. And I'll come back and I'll show you what we just did. Okay, I just did this across all the routers. I changed the reference bandwidth from 100 million to 10 billion. That's what I was trying to say as I was trying to type and think at the same time. So across all of these, I gave the same command. Okay, so that's actually showing 10 million. So, okay, that's in megabits. Strange, I know. All right, so how does that change our routing tables? Okay, let's take a look. Okay. Can I show here we go. Here was our routing table on MLS4 before. Okay, so all these links had a cost of 1. It's almost like half count, but 1, 1. So here from 1, 1. So that's 2. When I changed the auto cost reference bandwidth, let's scroll down here. You can see that I did that right here. Then I did a show IP route. I did that while I was on pause to make sure everything worked, everything converged. Yes. So now the gigabit links have a cost of 10. Okay. So gigabit is a cost of 10. If I had fast Ethernet link here, that actually have a cost of 100. Okay. If I happen to have 10 gigabit links, that would have a cost of 1. So now I can differentiate between 10 gigabit, 1 gigabit, and 100 megabit. Okay. So it doesn't really change our routing, but it does change, it allows us to be prepared for slower, if we put in a fast Ethernet switch here, well, this would turn to fast Ethernet or something happened, we have to swap something out. It prepares us for any kind of unexpected change and also for growth as we start to add 10 gigabit links. All right, next. Talk a little bit about forming an adjacency here. So when we configured OSPF and enabled it on these interfaces and on these interfaces here for MLS2, they formed an adjacency. Okay, we saw that. Let's go to MLS1 here. I'm going to kind of just put this right here. Maybe move that down a little bit. Here we go. All right. So let me do an exit here. I'm going to do a show IP. I'll do an exit here. Show IP OSPF interface. I'll just say enter. Gigabit 103. This interface right here. Let's take a look. Okay, right now our hello and dead timers are set at 40. Okay, so to form an adjacency with a neighboring router, our OSPF requires that our hello and dead intervals are the same. Okay. One of the other things it requires, by the way, is the same network type. We'll talk more about that in a moment. Broadcast, Ethernet. We'll talk more about that in a moment. So what this means is I'm sending hellos every 10 seconds. And I'm expecting hellos from you every 10 seconds. If I don't hear from you in 40 seconds, you get 4 chances to send me a hello. I'm going to assume that you are down. Okay. And I talk about this in great detail in class and also in the lab. When a neighbor is lost down, okay, it removes it from its neighbor table, neighbor list. It will generate new link state updates to its neighbor saying this neighbor here this what used to be a neighbor is no longer a neighbor of mine. We have to rerun an usually SPF recalculation, come up with a new SPF tree, a new routing table convergence, all that convergence stuff, okay? Because we have a new topology. All right, that's it in that part in a nutshell. But what I want to show you here is what happens when I do change the hello and dead timers. So I'm going to go into this interface gig 103. That's where I do this. Whoops, I've got to be in global configuration mode. Interface gigabit 103. Okay, that's where I make the modification. I say IP OSPF hello interval 5. So I'm going to change it from 10 to 5. Okay, now Cisco iOS will automatically change the dead interval to be from 4 times the hello interval. But don't rely on that. Change the dead interval to. I'll make it 4 times, 20. Now you're going to see something here. As soon as the previous dead timer expires, or now 20-second dead or dead interval, we're going to see that we're not getting hellos from anymore from our neighbor MLS2. Why is that? Because our neighbor adjacency, hey, we don't have the same dead timer. Our dead timer expired. And now I notice that, yay, we have different hello and dead intervals. So you're no longer a neighbor of mine. Really? Yeah, unfortunately. Let's take a look. Okay, I'm going to do show IP OSPF neighbor. Remember that quad 2 used to be in this neighbor table? If I went way up there, I'd show you that, but it's no longer listed as a neighbor. Okay. What do I need to do? Well, I can change it back, or let's modify this one. Yeah, let's do that. So I'm going to go down here and modify it on here. Now notice MLS2, it also notices, hey, you're no longer a neighbor of mine. Okay, matter of fact, if I show IP OSPF neighbor, yeah, I don't show you as a neighbor. I no longer have quad 1 in there. So let's do this, config T. I'm going to go, it's also my interface gigabit 103 interface. Gosh, I love this stuff. All right, let's do IP. Oh, I'm going to change it so mine's the same as yours on that interface. Make that a 5. IP OSPF. And I can just say dead here, but I'll do the autocomplete so you can see complete command. Now, as soon as I do that, hey, we can start forming a neighbor adjacency again. Look at this. Yeah, it looks like something's changed. I formed a neighbor adjacency with you again. Oh, that's wonderful. Okay, let's do an end here. Let's show. Hey, yeah, you're back. You know what? I bet you if we do the same command over here, we can see the same thing. Yeah, and you're back. All right. Now notice that these hello and dead intervals are interface specific. Okay, so we just changed it here between on this adjacency between MLS 1 and 2, but we didn't modify it here. Okay, that's fine. It's only specific for an interface. All right, we're doing really good here. But the other thing I want to mention is this. Okay, I won't get into designated, backup designated routers, but I do want to mention this. Let's go to, let's see which one I'm going to be changing here. Let's go to Edge here. Let's do it on a router. See, same thing. It's all the same, router or layer 3 switch. Okay, what I want to show is this. I'm going to do show IP OSPF interface. We only have one interface we're running it on, gig 000 right here with MLS1. But what I want to show you is right here. The network type is broadcast, and it starts talking about, hey, what am I'm a backup designated router. I won't get into all that here. And it says, who's the designated router? Designated router is quad 1. Backup designated router is basically when we have multiple, usually 3 or more routers all sharing the same network. If we I don't want to get into it too much here, but I had an Ethernet switch right here. And all of these 4 routers were all sharing the same Ethernet network. Okay, we have designated router and backup designated routers. It's really just for the sharing of link state advertisements. Okay, I'll talk about this in the class. Okay, but all of our inter-router links, they're broadcast, they're ETH-type broadcast, they're Ethernet, but there's just the 2 of us. That's all there is. Okay, we don't need to decide who's a designated router, who's a backup designated router, because there's just the 2 of us. Okay, we don't need to worry about that flooding that can happen when we have multiple routers all sharing this, all connected, say, by a Ethernet switch. Okay, and all sharing the same layer 2 segment. I'm sorry, I don't want to get into it too much, but what I do want to do is this. What I want to do is we don't need this, okay, this backup designated router stuff. Okay, so all I'm going to do here, and we'll do this on each of the interfaces, that Ethernet interfaces between the routers that have inter-router links. Let me do this first so I don't have to talk and type at the same time. I'm going to go to that interface here, interface gig 000. I'm on edge. And all I'm going to say is IP OSPF network. Okay. I'm going to change it from broadcast to point to point. Okay. Now you can see an adjacency has changed. Okay. Okay. The network type is something that has to be the same on with your interconnected routers. So what I'm going to do is pause the recording here. Okay, and I'll come back after I've done this on all the inter-router links. I'll point that out in just a moment. Okay, so let me show you what I did here. So there's MLS1. So I had to do that command, IP OSPF network point to point, on all the interfaces where I have a directly, my neighbor is on a Ethernet network, and I do have a neighbor on an Ethernet network, and that's just directly connected. It's just an inter-router link. Now, I did not do it here because I have no neighbor. We're going to talk about this in a moment. But so I did it on 1, 2, 3, 4 interfaces. 1, 2, 3, 4 interfaces. And if I go through here, you'll see the same thing. I have 3 neighbors, and I did it for all 3 of those interfaces. Okay. Now, what will we see? Okay, let's go back up here. If I do show IP OSPF neighbor, let's use our favorite gigabit 103 there. Okay. Okay. Oh, that's not the command I wanted to do. Interface gig 10. You probably say, why are you doing that command, right? No, the neighbor's there. There we go. This is what I want to show you. The network type, point to point. State, point to point. And you see nothing about it being a, you see no longer about DR or BDR. I think I failed to mention this earlier when we did the timer on this, right? The hello and dead timers. Notice those. Okay, but that's only for here, right? On this interface. Matches hello 5, dead 20. Okay. Love this stuff. Kind of cool, huh? All right. What else we got? We're almost there. Believe it or not, we're almost there. All right. One of the other things I like to do is just verify convergence. Everything's still working. Okay, you make a change. Before you just make a bunch of changes, make one change at a time, verify that everything's still there. So I did this while we were on pause, saw that everything's converged, we're good. You know, if anything looked out of the ordinary, I'd look at my neighbor adjacencies, I'd look at any timer issues, a lot of times when you're troubleshooting, think about what did you just change and what effect might that have had. Okay, the other thing I want to mention here is these lands here, we'll just call them regular local area networks here, these stub lands. There's no neighbors. So there's no reason that this router here needs to be sending out hellos every 10 seconds. Same thing here, okay? So what we're gonna do here is on that interface, so let's go. What I'm gonna do here is I'm gonna say router OSPF 1. I'm gonna say passive. I would say, I'm not saying it, am I? Not yet, I guess, not no voice recognition. Passive interface, gigabit 1024. Okay, what I'm saying here is I'm not going to be sending out any hellos out that interface. I don't expect any. Okay, that's all. Okay. Let's just do it to another one here. I think that's fine right now. What else do I want? Oh, very important. So let me exit here. I'm gonna do a show run here. Show run, running config. Oh, there we go. What I want to do is remind us of our OSPF configuration. Okay. Okay, so I just added the passive interface. Now that network is still network 10.1.1.0. I do not want to remove that. If I remove this, then I'm no longer going to advertise this link state, which means other routers will no longer know that they can get to this network somehow through SPF tree through me. Okay, so just important that don't remove that network command for this network. But what we are doing is say we're not going to have any neighbors out that interface. Okay. Let me show you one other thing here before I pause. I'm going to show this. Remember this do, by the way, if I failed to explain that correctly. A show command by itself here. Let me do show IP protocols. Okay, it says, hey, that's not going to work, Rick, because did I misspell something? No, it's saying, hey, no, I don't expect that there. You have to do that from here. Show IP protocol. Okay. Yes, I got to do that from this prompt. Can't do it from global config. But while I'm here, let me show you what I wanted to talk about. There's my passive interface. And yes, I'm still routing for that network. Okay. But if I am in global configuration mode, I can use that do and then a show. Now, the only thing with this is I can't use the tab, the autocomplete. Okay. I can abbreviate. I can just say do show proto or protocols. Oh, what's that? Oh, that's wrong command. Do show. I am messing up here. Okay. I was using the protocol to show protocol, not show IP protocol. But what I wanted to show you after all that, yes, you can use a do here. Okay. The autocomplete doesn't work, but you can still shorten it as long as it's unique. All right. You've probably seen me doing that a lot. I think we're just about there. Okay. All right. So we should have complete reachability still. Nothing's really changed. Should be able to ping 99. Yeah, even from our PCs, right? Should be able to. Okay. Yeah, even ping within our network 10.1.1. Why did that time out? Probably an ARP request, an ARP reply, probably here, PC or the route, maybe I'd do an ARP request for that device. All right. I think we're all set. Okay. Yeah. So again, what we would do is in the campus network architecture. If you're not there, part of this discussion, don't worry about it. But that's what we do here. We'd also configure OSPF here between these routers, layer 3 switches, and these core, the distribution core, and in between here, all OSPF, layer 3, easy, fast, and fun. All right. I hope this lab was helpful. I always enjoy talking about OSPF. Look at the lab in my GitHub repository. Students, you have the lab in my classes. Also, we talk a lot about this in my lectures. All right. Have a great day, everybody.